Okay. So what we're going to work on today is friction system. It's just some more practice, but maybe with a little bit more intricate workings. You'll see in a second. Like this. So we've got a mu of static friction is 0.32 for all surfaces, and both of these blocks are 10 kilograms. So make a free body diagram for the upper block and make a free body diagram for the lower block. Okay, so here's the upper block, not drawn to scale. What is going on with the upper block? Do you think you know? Well, it's got a force of gravity. The force of gravity is 98 newtons, right? That means it's not going up or down, so it's got to cancel out. So the force normal is going to be 98 newtons. You want to put Fn and Fg? I don't know, whatever helps you out, man. Now, theoretically, this box is not going to be moving, so everything should cancel out. So what's going this way is the force of tension, right? Now, when we pull this block out, pull the lower block, it's going to pull with friction this way. So this is going to be F of F, force of friction. Ta-da! So that's good enough. Alright, make a free body diagram for the lower block. Now, let's see here. What kind of forces do we have? We've got this force, which is the applied force. I'm just going to use F naked here. Now, we've got a frictional force. I'm going to call this F, and I'll call it FF1. I'm talking about this friction here. Does that make sense? Now, you're also going to have F2. Now, do you really need to worry about it? You can. There's ways to combine them together, but that's the friction from the top block. Because the top block is also going to be holding the one block back. Does that make sense? I'm just trying to split things apart as much as possible. Alright, so you're going to have F of G, and you're going to have the force normal. Force normal. Now, you're also going to have sort of a force from the top block. You want to call it normal 1, normal 2, because that's like this force here. You know, so this force normal is going to be both of them together, the original force normal. Okay, I don't want to get lost in the labeling because it also depends on how you think of it. Anyways, let's figure it out. What is the magnitude of the normal force on block 2 that comes from block 1? So that would be on block 2 from block 1. So the normal force of there, well, that's just going to be 10 times 9.8, right? That's going to be this guy right there. So I'll put number 3 here so it doesn't get too tangled in all this mess. 98 newtons. What is the magnitude of friction force that the surface applies to block 1? I guess we're talking about this guy. So this one right here is what we're talking about. So we're talking about this for number 4. Alright? So F1 is going to equal mu times the normal force, right? The mu is going to be 0.32, and the normal force is going to be this guy, alright? Now that guy is going to be the two blocks glued together. So just pretend they were glued together, that this frictional force wouldn't care at all. Okay, so we're going to have 20 kilograms. Can I just do 20 times 9.8? Because, you know, that's the force of gravity is going to equal that. Alright, well, hopefully you said yes, because I wrote it anyways. 0.32 times 20 times 9.8. So this is going to be 62.7 newtons. Fun. What is the maximum applied force that will allow the system to remain at rest? Okay, so we've got that. Now we need to figure out what the other frictional force is. So basically what we know is your applied force has to equal your friction force 1 plus your friction force 2. Does that make sense? Because once you cancel both of those out, then you start to move. Now, your friction force 1, we already figured out. I'm not going to rewrite all the formulas for it. It's just 62.7. That's what we just did. Plus your friction force 2, right? This guy comes from the force normal here, right? Well, because this block is pressing down on it. So there's this normal force there. So what do? So we're going to have 0.32 times 10 times 9.8, right? Because it's just the weight of the top block. Alright, so 0.32 times 10 times 9.8, enter, plus 62.7. Oh, okay, I'll do 72. Alright, so 94.1, just about, Newton. Alright, that's how hard you can pull on it before it will booge. Wasn't that fun? Let's do another one. Okay, here's something fun. In the figure there, the coefficient of kinetic friction between the 2 and the 3 is 0.3. So I'm just going to write that down real quick. Mu is equal to 0.3. The horizontal surfaces and the pulleys are frictionless. Ooh, so fun. Mu is equal to 0. Draw a free-body diagram for each block. Okay, let's do the first one first. First things first. So this is the 2. So what do we got? We've got FG going down. We've got F normal going up. And we've got tension 1. I'm gonna do FT1 because it kind of bothers me without the F. And that's it. That's all there is. That's all there. Oh, no, I'm sorry. That's not all there is. Because there's friction between these two. So there's going to be another force of friction right there. So fun. I think that's the only force of friction, so it doesn't need any more subscripts. Alright, let's do the 3. Do you think you got it? You can pause the video to try it. Alrighty, so this guy right here is going to be FT2. This guy right here is going to be FT1 because, you know, each tension is pulling it left or right. This guy right here is going to be FG. And this guy right here is going to be F normal. Now, if you want, what we could add in here is this is FG from the 2 kilogram block, and the normal force is going to be both of them together. You could separate them or keep them together. It doesn't, you know, it doesn't really matter. Mathematically speaking, it's just categorically, so it's just how you think about it. I'm not going to do the free body diagram for the ball because who cares? It's just going down and up. I don't think it wants it anyways. It says block. Alright, let's do part B. Determine the acceleration for each block. Well, accelerations are going to be the same. Alright, well, I'm going to need this. This is going to be 98 newtons. Nice. Okay, so what are we going to need here? So this guy right here is going to have a gravity force and a normal force. The normal force is what I really care about. 2 times 9.8 is going to be 19.6, which means that the friction force for him is going to be times 0.3, which is 588. Ta-da! Alright, now let's look at the bottom fella. The bottom fella, oh, this is no friction, but he is going to have a friction force right here of 588, just like the top guy did. Because that's the normal force for that part. Okie doke. Alright, so is that all the forces we've got? I believe it is. So let's do our net. So force net is going to equal m times a. Maybe you've heard of this formula. Alright, so 98's going the correct way, but we have a 588 going backwards, right? And then we have another 588 going backwards. So minus 588. This is going to equal m. What's m? 2, 2, and 10 makes 15 times a. So now we just have to type this fella in. 98 minus 5.88 minus 5.88. Enter, divide by 15. So a is equal to 5.75. Nice. That's going to be for everything because it's all tied together. Find the tension in the strings. Well, let's do the easy string first. Let's do this one. So here's the ball. It's 10. FG is 98, and we have FT, right? Oh, sorry, FT2. Don't want to get sloppy here. Well, we know that it's accelerating downwards at 5.75, so that means the net force is going to be 57.5, because 10 times that, right? So force net is equal to force G minus force T2. So this is going to be 98 minus something. Alright, so FT2 is going to equal 98 minus 57.5, 40.5. Alright, now let's, I'm just going to work backwards here and do the 3 block, right? Here's the 3 block. I don't care about the up or down forces right now, but I know that this tension, this is FT2, and this is going to be 40.5 because we just figured it out. Minus, oops, well not minus, but going this way we have force of friction, which is 5.88, and we also have the tension 1, FT1. Alright, ta-da! So I know that it is accelerating this way, so that's going to be my net force direction. So my net force is going to be 3 times its acceleration, 3 times 5.75, which is 17.25. Now, let's see, what's going the same way? That's going to equal 40.5 minus, because everything else is going the opposite way, 5.88 minus FT1. Phew, made it. Okay, doing some quick maths here. Right, are we okay with that? Ta-da! Move that over, move this over, so we're going to have 40.5, just checking the signs, sorry, 40.5 minus 5.88 minus 17.25, so we are going to get FT1 is equal to 1737. You could have also done the top block, wouldn't have mattered, you should get the same answer. I'm out of room, so I'm not going to do that. Okay. Hopefully that makes sense. If not, oh, bummer. Okay. Well, I think we have one more. Oh yeah, here's a fun one. The 3 blocks in figure whatever are connected by massless strings. I love massless strings that pass over frictionless points. I gotta get me some of those. The acceleration is there. Oh, nice. It even told us 2.35. To the left, so it's going to go that way. And the surfaces are rough. Find the tensions in the strings, and B, the coefficient of kinetic friction between the blocks and the surfaces. Okay, so it's basically the second half. See if you can figure out the tensions. I'm going to do T1 first, and then T2. You pause the video, see if you can do it. If not, well, don't pause then. Alright, looking at this one, I've got a 98 Newton force here, and this is my FT1. So since I know the acceleration, oh, it's 10, which means I can do it easy. So 23.5 is going to equal 98 minus my force of tension 1. So 98 minus 23.5 is going to be 74.5. So Ft1 is equal to 74.5 newtons. So awesome. Alright, now I'm going to look at this block here. So I know that this force of tension is 74.5, and I want to know what Ft2 is going to equal. Well, I know the net force for that one is going to be 5 times 2.35 times 2.35, which is half of that, so 11.75, and that's going to equal our force of tension 1, so that's going to be 74.5 minus the force of tension 2. Oh, but we also have a friction, so this is going to be 49 newtons. This is going to be 49 newtons, right? Ooh, should we just figure out what the coefficient is first? Because there's going to be a frictional force right here. Friction F. I'm going to say FF5 because, you know, that's what it is. Okay, so we'll come back to this in a second here. FF5, because it's the 5 block one. Alright, well, let's figure out the last one here. So we're gonna do all the forces, then we'll come back to the friction here. So 3 times 9.8 is 29.4, 29.4 newtons. So there's going to be some of this action here, 25. Alright, so that times sine of 25 degrees is going to be 12.4. 12.4. And then, if I do the cosine version, it's going to be 26.6. Alright, that means the normal force is 26.6, and that means the frictional force is going to be mu times 26.6, just like this one is mu times 49. Right? I mean, you could replace that, but we wouldn't be able to go much further with it. Okay, so now what we're going to do is we're going to add up all the forces going to the left, take away all the forces going to the right. Right? Because F is equal to ma. Have you heard of this formula before? So going to the left, we have a 98. Not going to worry about the tensions because those just cancel each other out. And then we have a minus the force of friction 5, which is going to be mu 49. Are you okay if I just do that? Okay, and then minus mu 26.6. Right? I'm just looking at all of them, and I also have a minus 12.4. Those are all the forces that are going against motion. Take away from the 9.8. The 9.8 is pulling through all of that. Alright? Equals mass. I know what the masses are. I've got a 3, a 5, and a 10. That's 18. Times the acceleration. I know what the acceleration is. It's 2.35. Ooh, barely. Alright. So doing some quick maths here. I'm going to have 98 minus 12.4 minus 18 times 2.35. Alright, so I know that 43.3 is going to be equal to 49 plus 26.6, 75.6. Mu. Alright, hopefully you're able to meet me there. And then that means that we're going to do 43.3 divided by 75.6, enter. So mu is going to equal 0.57. Alright, no units for that puppy. Woof. Now let's go back and finish part A. So all we need to do is we can plug it into this area now. Since we know what mu is, so we can figure out what this is. This is going to be 49 times whatever that number was, which is 28.1. Alright, that's how many newtons the friction force on number 2 is. So now I know that 11.75 is going to equal 74.5 minus force tension 2 minus 28.1. Alright, so doing some quick maths here, I've got 74.5 minus 28.1 minus 11.75, 34.7. Newtons, because it's a tension force. Alright, wasn't that fun? Hopefully that made sense. Sorry we had to switch gears in the middle there, but it wasn't that bad, was it? Alright, we'll see you tomorrow. Be sure to like and subscribe.